In this tutorial, I will show you how to identify the slope and y-intercept of a linear relation when given an algebraic equation. Now here's the question. Identify the slope and y-intercept of the following linear relation, y plus 2x equals 3. Now the easiest way to identify the slope and y-intercept given an equation is to first rewrite the equation in slope y-intercept form. Now we're going to have to review what slope y-intercept form looks like. Slope y-intercept form has the y isolated and then we have the slope in front of the variable term x, and then the y-intercept at the back. And we use m and b to describe the slope and the y-intercept. Now, this coefficient of x is what we refer to as the m value. And this b value would be the constant term. So a little review of algebraic terms. Now let's take a look at an example, and we're going to call a lesson where we studied slope y-intercept form of a linear equation. Now here we go. Let's take a look. Here's the equation, and we can identify the coefficient of x as being 2, and the constant term in this case is 3. And if you notice on the graph, we can use a rate triangle. Notice the rise is in purple, the rise is 2, and the run is in red, the run is 1. Rise of a run is slope, 2 divided by 1 is 2. We notice the slope is just the coefficient of x in the equation in slope y-intercept form. Now to identify the y-intercept, this one's pretty easy. If we look on the graph, it's where the line crosses the y-axis. There it is at 3. Notice it's at 3. Let's change this y-intercept. Let's make it a little bit higher. Notice the y-intercept now is at 5. Notice on the equation, the constant term is now 5. And similarly, we can go down, and the same occurs. A -2, y-intercept's at -2. Same with the slope. If I modify the slope, make it steeper, the slope of 6. Looking at the graph, the rate triangle shows rise is 2, run is 0.33. The slope is 6. We can identify the slope being 6 by taking a look at the equation. Okay, and the slope as well can also be negative. -2, -2. So that's the easiest way of identifying the slope and y-intercept given an algebraic equation, by rewriting the equation in slope y-intercept form. So let's take a look at what we're given here. We're given an algebraic equation that looks like this. Y plus 2x equals 3. Now if you notice, this equation is not in slope y-intercept form. Why? Because the y is not isolated. We have y plus 2x on the left-hand side. So what we're going to do, I'm just going to clone this, is we're going to rearrange this equation so that y is isolated. And what we're going to need to do is we're going to bring this 3 is fine on this side. I'm just going to put it at the back because the constant term's at the back. And this 2x, I'm going to bring it to the other side. Now when I bring it to the other side, don't forget, let me clean this up here, that we have to change the sign. And so this positive 2 now becomes -2. So we have -2x, and now the 3 on the right-hand side was positive. It didn't move, so it stays positive 3. And just by isolating y, we now have the equation of a line in slope y-intercept form. What we can do from here is easily identify the slope as the m value, which is the coefficient of x, as -2. And in this case, the y-intercept I'll use y-int for short, would be the constant term, which is 3. And there you have it. That's how we find the slope and y-intercept of a linear relation when we're given an algebraic equation.